So we're going to take from the confidence interval to talk about a hypothesis test. So that's where we consider a previously known estimate of the population mean in this case, but we still have an unknown standard deviation for the population. If you know the standard deviation of the population, you can treat this a little different sometimes. So big considerations for hypothesis tests for a mean. You either need to start with a few things. You need some idea about what a previous null was and a claim about it. Then you need, so that's population information. Then you need some sample information. As far as the sample goes, either you need the whole sample or you need the summary statistics. And for summary statistics, we want to know how big was the sample, what's the mean, what's the sample standard deviation. Otherwise, you need the original sample so you can calculate those yourself. We'll do one of those next. Otherwise, the central limit theorem tells us that the standard error is going to be the sample standard deviation divided by the square root of the sample size. And your test statistic is a T, and that's X bar, right, the sample statistic, minus whatever the null value is, divided by your standard error, which we now know is that. And on some calculators, that has to go in parentheses unless you pre-calculate it. And usually in a spreadsheet, I pre-calculate it, so I don't need parentheses, right? Order of operations says do this before you divide. That's what I mean by pre-calculate there. So be careful about that. On a handheld calculator, if you were doing that in one shot, you'd also need the top to be in parentheses. And if we look back at my spreadsheet, you'll see I did have those parentheses in there. Once you have that information, then you can find the p-value. A p-value is a proportion. It's a percentage of something happening, a probability. And in this case, that's going to be a t-dist on the spreadsheet or the t-dist in StatKey. And there's a few different versions of that in the spreadsheet we got to puzzle out. So our situation here is human body temperature. So humans would be our population. Our parameter is mean body temp. The claim for the null hypothesis would be that it is 98.6. The alternative here could be that it's not, that it's greater than or it's less than, and based on my calculations here for the confidence interval, my sample statistic was less, and the upper end of my confidence interval was less. So I'm going to say, hey, I think it's less. And we've done this before, but with a randomization. I'm just going to redo this idea with a central limit theorem. So mu is less than 98.6. That's a left tail, which is nice because spreadsheets do left tails easier than right or two tails. So next we calculate this stuff right here. Let's see, what should our alpha be? Is it a big deal that human body temperature on average seems to have dropped? I guess that makes the threshold for a fever slightly lower. So I think I'm just going to go with the 5%. Alpha is 5%. Standard significance level. So I need to know what the standard error is. And that means I need these summary statistics. So let's see, what did we have? N was 50, X bar was 98.26, and S was 0.765. So our standard error is going to be that 0.765 divided by the square root of 50, which we calculated earlier was about 0.1082. Let's see, how's my memory? Yep, that's what I claimed based on my calculator. And then the test statistic, which we didn't find back there, takes into consideration the null hypothesis. So my sample said the mean was 98.26. I want to know how far that is from what the null says, 98.6. Then I want to measure that distance in terms of the standard error. How many of the standard errors, how many of this length is that distance right there? Is it more than 2 standard deviations from the mean? I don't know. Let's whip out a spreadsheet and do it. So let's see, spreadsheet time. I'll drop my spreadsheet over here. All right, so what do we got here? I got to zoom out just for a sec to see this better. We have confidence interval for a mean, and I do need some of that information there. So I guess I'm going to duplicate this and then clean it up. This is hypothesis test for a mean, and blow it back up so you all can see it. And if you, ooh, whoa, too big, too big. If you lost the link to this, I will reshare it in the chat and in the YouTube description. Huh, interesting. So I'm just looking at the chat. Sure. Yeah, we'll look at a homework problem next. All right, so let's see. We are doing a hypothesis test here. So I do need the standard error. Instead of a confidence level being given, I have alpha up here. .05. And then let's delete this stuff for now. So based on the above information, I can find the standard error. And then I want to find my test statistic. I'm just going to call that T here. And that is equal to parentheses to do the subtract. Oh, I don't have my null hypothesis in here. Aha. Let's put that up at the top. Let's insert a few rows. This is human body temp. And my null hypothesis, H0, is, now, in a word processor, you can go and insert special characters. That's not easy to get here, but I can just go search for mu, the symbol, on the internet, and copy and paste it in. Where's my mu? Oops. Oh, I got it in there before. So mu equals 98.6. And the alternative always uses that same number, so I can just go equals, get that number again. HA is greater than. And if you wanted a greater than or equal to, like I searched for the mu symbol, you can just search for the greater than or equal to symbol. All right. So now I get everything I need. So to get the T statistic, that's the difference in our sample mean from the null hypothesis mean. So that shows it's below average, and we want to know by how much using the standard error as the measuring stick. So this says it's more than 3 standard deviations below the mean. So that is a unusually far from the mean T or Z score. Next, we can find the p-value. Draw a picture of what this means. So the p-value, since I used a t, I have to use the t dot dist. So there's the t dist, the right tail, and the two tail. So if we were doing a right tail test, I would grab that. But this is a left tail, so I can just use the regular t dist. And then what does it say? It wants the degree, no, it wants x, which would be my t-score, right there. Then it wants the degrees of freedom. So that would just be my sample size -1. And then it wants to know if it's cumulative. And the norm dist always wants to know that too. And that's always true for us. And so it gives me a p-value of 0.0014. compare this to the picture stat key draws. Let's take a look at that. So stat key, theoretical T distribution. As soon as you open it, it says, hey, what's your degrees of freedom? That's n-1. So in this case, I would say 49. In here, you can't type 50 minus 1. It'll get confused. You got to actually do the math first, 49. And then in this case, I want to do a left tail, and then I come down here and enter my t-score, which I have to pre-calculate. So what was that, negative 3.14-ish? 3.1427 here, 3.1427. And it says 0.0014, and it draws that picture, which is nice. I usually like to draw my own in my notes. So let's put that all in here. So just kind of squeeze this in on the bottom. I've got my t distribution, which really looks like a normal distribution. It's just a little more spread out. And in the middle is my null hypothesis, 98.6. I have a value from my mean, x bar, of 98.26, and the standard error basically tells me how far to look to the left. So 1, 2, it's more than 3 standard deviations to the right. By just a little bit, it's over here. So this is my 98.26. And again, it has a t-score of about negative 3.1427. Yeah, that's what it was. Yeah. And based on that, both the spreadsheet and the stat key agree that the p-value there is 0.0014. So there's less than a 1% chance of finding a group of 50 people that have an average temperature that's less than 98.26 when we're expecting their temperature on average to be about 98.6. What do I do here? Reject the null, fail to reject? Do we have evidence that body temperature is around 98.26 or less than 98.26?
You fail to reject because the p-value is less than the significance floor.
That's when we reject. So
sorry.
If the p-value is small, we reject the null. And that means we have evidence for the alternative. This is a weird situation if we think the null is true. If we think we have a good random sample, that means there's something wrong with the null hypothesis. So this supports the alternative here. So 2 things, quick decision, reject the null. And then the conclusion, and even if the problem doesn't ask for a conclusion, try to write one up just for your own benefit, just to practice. Feel free to email me saying, hey, for this problem, is this a good conclusion? This is what I thought. And the conclusion just means state what it means to reject the null in this case. So in this case, I would say we have sufficient evidence that human body temperature is less than 98.26. So evidence, body temp is less than. Can we say it's 98.26? The answer is no. However, we do have a confidence interval that says, based on this sample, we think human body temperature is more like somewhere in between 98.04 and 98.5. So we could err on the side of upper, since we thought it was higher than that, and say, oh, it looks like human body temperature might be more like 98.5. So then we ask the question, is this practically important? Does it matter whether we think human body temperature is 98.6 or 98.5 when we're trying to figure out if somebody might be too cold or too hot? Practically, I don't think it's a huge deal. So does this have statistical significance? The answer is absolutely. Is it practically significant? Not to me. Not when I'm checking to see if my kid's sick or if I might be hypothermic. 1/10 of a degree off, I don't think is a huge deal. Now, being a few degrees off, that turns out to be a big deal for humans, right? If we're too hot for too long, we're gonna have a problem. If we're too cold for too long, we're gonna have a problem. That's another issue. But practically, it's statistically significant, but not practically significant. Could I have made a mistake? Yes. So a type 1 error is when we reject the null. Like this is a situation where I could have made a type 1 error. Type 1 error means you decided to reject the null, but in reality, it's really true. Human body temperature is about 98.6. You stating it's lower is incorrect. You just have a weird sample. What's the chance of me getting a weird sample? We set the threshold of getting a weird sample at 5% here. So there's a 5% chance that I just made a mistake by saying it's lower, but it's really 98.6. That's a type 1 error. Okay, next problem. Let's see. I'm going to do a very homework-like problem right now.